everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
This video is all about the tutorial for the chapter 7 and the chapter 7 entitled IP addressing. So let me read this first. So addressing is a critical function of network layer protocol. So it says here that it is critical. So um, it's a critical function. Then addressing enables data communication between hosts regardless of whether the hosts are on the same network. So um, because of addressing, the data can communicate between the hosts regardless of if they are in the same network. Then both Internet Protocol version 4 or the IPv4 and Internet Protocol version 6 or the IPv6 provide hierarchical addressing for packets that carry data. So the IPv4 and the IPv6 both provide the hierarchical addressing for packets that carrying that data. So designing, implementing, and managing an effective IP addressing plan ensures that networks can operate effectively and efficiently. So the designing, implementing, and managing an effective IP addressing plan ensures uh, it ensures that the network can operate correctly. And this chapter examines the detailed structure of IP addressing and their application to their construction and testing of IP networks and subnetworks. So let's start with the IPv4 addresses. So binary is a numbering system that consists of the numbers 0 and 1 called bits. So in the binary, so we only have two numbers. It's either 0 or 1. And the 0, 1 is called bits. Then, in contrast, the decimal number system consists of 10 digits consisting of the numbers 0 to 9. So, in decimal, it consists of 10 numbers. It is a 0 up to 9. So, in binary, it's consisting to numbers 0 and 1 only. And in decimal, so it has 10 consisting numbers. It is from 0 to 9. And binary is important for us to understand because host servers and network devices use binary addressing. So the host servers and the network devices use the binary addressing. Then they use binary IPv4 addresses as shown in the figure 1. So just like this one. So it consists of 1 and 0. So that's why it is binary. So let's try with the figure 2. So they are in the dotted decimal. So I said before that the decimal is consisting of 10 digits. So it's only from 0 up to 9. So it has a dotted here. So just like this one, the IP address. So this one. And next is contrasting PC1 IPv4 data decimal and binary address. So this one is for the decimal and then they they convert it into binary. So this one. So the 192, the equivalent in the binary the decimal 192, the equivalent for in binary is the 11000000. Then in 168, it is a 10101000. And in 10, it is a 00001010. And then 10, same as this one, so 00001010. So the 192.168.10.10 is an IP address that is assigned to a computer. So try with the octet. So this one are the octets. So the dotted decimal address is this one. Then the octets are this one. This one, and this one. This four. Then the 32-bit address is this one. All of this. So this one is the dotted decimal address. The octets is 1, 2, 3, 4. 4 octets and the 32-bit address. So all of this one. And the compositional numbers. So this one is the radix. The first row identifies the number base or radix. So this one are the radix. Then position and number. It's 0, 1, 2, 3. The second row considers the position of decimal number starting with the from right to left. So it starts here. That's why it's 0, 1, 2, 3. Then calculate. Uh, the orange one are the position. So 0, 1, 2, 3. Then it says the third row calculates the position value by taking the radix and raising it by the exponential value of its position. Noted n raised to 0 is always 1. So this one is the position value. So 10 raised to 0 is 1. 10 raised to 1 is 10. 10 raised to 2 is 100. And 10 raised to 3 is 1000. So this one is just like the recent figure. I'm going to talk to you about the binary binary to decimal conversion. To convert a binary IPv4 address to its dotted decimal equivalent, divide the IPv4 address into 4 bits, octets, then next apply the positional value of first octet binary, calculate accordingly. So these are the positional value, the 1, 2, 4, 8, 16, 32, 64, 128. So if we have the binary of 1, 1, 0, 0, 0, 0, 0, 0, it means that if our positional value is has a 0 in this binary number, it means that it is 0. So since that 128 and 64 only has a 1, so we will just add 128 plus 64 equals to 192. Then the decimal value is 192. Then this one is the different example. So for this one, the 10101010000. So it means it here. So the 1, 2, 4 is 0, so that's why it is all 0. Then 8, it has a 1, so that's why it's 8 here. Then 16 is 0, so that's why it is 0. Then in 32, it has a 1, so it means that it is 32. Then 64 is 0, so that's why it's 0, and 128 is 1, so it's a 1, so 8. So the result is 1, if we add 1 to 8, 32, 8, we will have a sum of 168. So this one, the 0000101. So it means 1 has a 1, so it means 1. Then 2 has a 1, so it means 2. Then 4 is a 0, then 0. 8 has a 1, so it means 8. So all of these are 0, so it means that it's all 0. So 8 plus 2 plus 1 are 11. So this the result is 11. Then the last one is the 000011010. So just like uh, uh, the previous, so just like 1 is 0, so that's why it's 0. 2 is 1, that's why it's 2. Then 4 is 0, so 0. 8 has a 1, so we have 8. Then the rest are 0 because it has a 0 in binary. So 8 plus 2 equals to 10. So to convert the 1 1 dot 10 dot 0000 dot 10 dot 0000 dot 0000 1010. If we convert that into decimal, the answer for that is 192.168.11.10. So let's try this. Uh, it has what you call that, value. So the 192 verse is 192. So we will convert it to the binary, the 192. So it says here that 192 is greater than or equal to 128. So yes. So that's why we put 1 here. If yes, we will put 1 here. Then 192 minus 128 is 64. Then we have a 64. So 64 is greater than or equal to 64. So yes. So we will put 1 again. Then 64 minus 64 is 0. So that's why it is a 0. It means that 11000000 is equal to 92. The next is uh, we are now in the 168. So the 168 is greater than or equal to 128. So yes, we will put 1 in the 128. Then 168 minus 128 is 40. Then 40 is greater than or equal to 64? So no. So it means that we will put 0. So 40 is, next one is 32. So 40 is greater than or equal to 32. So yes. So that's why we put 1 here. Then 40 minus 32 is 8. We have 8. And next is in 16. So it means that it is uh, 0. Then in 8, 8 is greater than or equal to 8. So yes, that's why we add 1 here. So it means that we're all 0 because up to this 8, so it become exact 168. So the uh, equivalent value in decimal are in binary is the 10101000. So next one is the 10. So just like we did, so 8 is greater than 0, then 8 plus 2 is 10. So that's why we have 000001010. Then the last one is the 11. So the 8 plus 2 plus 1 is 11. So that's why we have 000001011. The subnet mask, as shown in the figure 1, 3-dotted decimal IPv4 addresses must be configured when assigning an IBP4. So, the IPv4 address, unique IPv4 address of the host. So, the host should be has a unique IPv4. So, the IPv4 address is uh, the identity of the IPv4. So, it must be unique. So, just like this one. The subnet mask used to identify the network or host portion of the IPv4. So, it says here that to identify the network or the host portion of the IPv4, the subnet mask is used to identify it. So, the default gateway is the identifies the local gateway to reach the remote. So, the default gateway, we all know that we are mm, putting it in the PC. So just like example, we configure a router. We put the IP address of the router. So the default gateway, then the PC is connected to that router. So the default gateway of the PC is the IP address of the router. So the logical end, a logical end is one of the three basic binary operations used in digital logic. They're true or not. So let's focus on this one. 1 and 1 is 1. 0 and 1 is 0. 0 and 0 is 0. 1 and 0 is 0. So just like this one, so this one are the just like here. So 1 and 1 is 1. Then 1 and 1 is 1. Then if we are all 0, it means that it is all 0. Then 1 and 1 is 1. 0 and 1 is 0. 1 and 1 is 1. 0 and 1 is 0. Then 1 and 1 is 1. Then all 0 again. Then all 0. Then 1 and 1 is 1. 0 and 1. 0 and 1 is 0. 1 and 1 is 1. And 0 and 1 is 0. So then we will convert it into decimal. So the answer for that is 192. This one is the 168. This one are the 10, and this one are all 0. That's why it is 0. The prefix length, so it means here slash 8. So these are the subnet mask. So and this one is the 32-bit address. So the subnet mask uh, convert it into binary. So the prefix length is the uh, number of 1 here. So it says here in the first that it is slash 8. So because it has 8 1 here. Then slash 16. So it has a 16 D here. And this one is 64. This one is 25. This one is 26. This one is 27, 28, 29, and 30. Types of addresses in a network. So, network address. Address and subnet masks refer to a network. Address and subnet mask. All hosts within the network share the same network address. The host portion is all zero. So that's one. This one is the host address. Unique IP addressing assigned to the host and devices. So the host address must be unique. Uh, it is assigned to the host and devices. The first host is the first available host IP address in that network. So the version always has a 0 and 1 and ends in 1. Last host address is the last available host ID address in that network. The host portion always has a 1 and ends in 0. Then the broadcast address is a special address for communicates with all hosts in a network. For instance, when a host sends a packet to the network broadcast IPv4 address and all other hosts in the network receive the packet. So let's proceed to the next. So this one, static IPv4 assignment to a host. Devices can be assigned an IP address either statically or dynamically. So the devices, so it can assign the IP address, so it can be statically or dynamically. So in some networks require a fixed IP address. So let's do it first in the dynamic IPv4 address. Assignment to a host. In the most data networks, the largest population of hosts includes PCs, tablets, smartphones, printers, and IP phones. So they're the largest population of hosts. Then it is often the case that the user population and their devices change frequently. The IPv4 communication, the unicast. So the unicast, the process of sending a packet from one host to individual host as shown in the figure. So let's try. Let's focus on the unicast. So let's try this one, this figure. So it says here that from one host to an individual host. So just like what? This PC, the 172.16.4.1 to this printer, the 172.16.4.253. So it means that one host from an individual host. So the process of sending a packet from one host to all hosts in the network. So let's try with this. So the broadcast is from one host to all hosts. So then the next one is the multicast, the process of sending a packet from one host to a selected group of hosts, possibly in different. So it means that it is a selected. So it should be here and this one only. So let's recall that the unicast is from one host. So it's like from this one up to this one. Then in broadcast it is from this one to all hosts. And in multicast, so it is only a selected group. Unicast transmission. Unicast communication is used for normal host-to-host communication in both client to serve. So just like before, so it is from here up to here. So from one to one host only. So the broadcast transmission, I said it also before that it is for all hosts. It is from here, then from for all hosts. Then the next one is the uh, multicast transmission. So multicast transmission reduces traffic by allowing a host to send a single packet to a selected set of hosts that subscribe to a multicast group. So it means that it is a selected. So it is only for here, for this one. So this one is only for the two PC or the two laptop. So special user IPv4 address. The loopback address 172.0.0/8 or the 172.0.0.1 to 127.255.255.254. More commonly identified as only 127.0.0.1. These are special address used by the host to direct traffic to itself. So it is used to direct to direct traffic to itself. So legacy classful addressing. So there's class A. So let's focus on the class A first. So the address block is from 0.0.0.0 up to 127.0.0.0.0. So the default subnet mask is /8.255.0.0.0. The maximum number of networks is the 128 and the number of hosts per network is 16,777,240. The high order bit are this one. Then it says here that 0.0.0.0 and 127.0.0.0 are reserved and cannot be assigned. So they are reserved, it cannot be assigned. Letter B is from the address block is from 128.0.0.0 up to 191.255.0.0. The default subnet mask is slash further slash 16 to 255.255.0.0. Maximum number of networks is 16,384 and the number of hosts per network is 65,534 and the high order bit are this one. Then the class C is the address block is the 192.0.0.0 up to 223.255.255.0. Then The default subnet is the forward slash 24. Then the 255.255.255.0. Then the maximum number of networks is 2,097,152. And the number of hosts per network is 254. And the high orbit is this one. The need of IPv6. IPv6 is designed to be a successor to IPv4. So, I said in a previous activity about the IPv4, the limitations of that. So, that's why the IPv4 is discovered. So, IPv4 has a larger 128-bit address space, providing 340 undecillion address. So, the IPv4 provided 340 undecillion addresses, so it is a much bigger than the IPv4. So the need for IPv6, the depletion of IPv4 address space has been the motivating factor for moving to IPv6 as Africa, Asia, and other areas of the world become more connected to the internet. There are not enough IPv4 address to accommodate this growth. So because of the so maybe the rapid uh, and more connected people to internet. So that's why the we need the IPv6 because the IPv4 is not enough for the address space. Then internet of everything. So the internet of today is significantly different than the internet of the past decade. So the internet of today is more than email, web pages, and file transfer between computers. So the internet is more useful or it is more commonly used nowadays. So every move we need an internet. So that's why it is a need for us. IPv4 and IPv6 coexisted. So the migration techniques can be divided into three categories. So the dual stack as figure. So this one are the dual stack. So it says here that dual stack devices run both IPv4 and IPv6 protocols stack simultaneously. So it can run in IPv4 and IPv6. Then in a tunneling. So in the first one is the IPv4 only network. Then here IPv6 only network. This one are the dual stack, and then the IPv6 only network. Then in the three is the translation. So IPv6 only network, IPv4 network. So they translate. So allows IPv6 enabled devices to communicate with IPv4 using translation. So, because of this one, the NAT64 router, the IPv6 and IPv4 understand or able to communicate each other. So, the IPv6 address representation. So, this one are the format for the IPv6. Says here that it is a hex text. So IPv6 addresses are 228 bits in length and treated as string and hexadecimal values. So it is in the IPv6 is written in the hexadecimal values. So there is rule number one: omit the leading zeros. So this one, uh, it is leading zero. That's why it is omit here, and these are so they omit this one, this one. The orange color they omit it because it is all a leading zero. Next one, just like this one. So all the leading zeros must be omitted. The rule number 2, omit all zero segments. The second rule to help reduce the notation. So, this one, they omit the zero, zero. So, it means that it is all zero, so they omit it all. So, just like this one, they omit it all also, and this one. It is to compress or to reduce, to help reduce the notation of IPv6 address. IPv6 address type. So the unicast interface. So this one is the unicast. So it is from one host to another host. So one is the source and this one is the destination. The multicast is an IPv6 multicast address to send a single IPv6 to a multiple destination. So uh, it is from the so just like this one, and to the multiple destination. Then any cast address to any user can be assigned to multiple. So in any cast, so it means that in any destination. The IPv6 link local unicast address. An IPv6 link local address enable a device to communicate with other IPv6 enabled devices on the same link and only on that link. So these are the IPv6, so the destination and this one. The uses of IPv6 link local address. The routing protocol is I will send so just like this one. I will send my routing information to the other router's link local address. So I will send my routing information to the other's one. So I will use the routing protocol. So I will use the router's link local for my default gateway. So for it to use. So this one is for to use the link local address is used for this one. So send the information. Static configuration of global unicast address. Router configuration. Most IPv6 configuration and verification command in the Cisco similar. The use of so just like this one. Converting the or configuring the IPv6 on a router. So just like this one. So interface gigabit Ethernet 0/0 then IPv6. So in IPv port, so we only use the IP address. So in IPv6, we will use the IPv6 address, then the address, then the no shutdown for saving, then exit to go back to global, then interface gigabit address 0/1, the IPv6, then no shutdown for saving, and then we'll exit, then the interface 0, then the IPv6, the clock rate, and then the no shutdown. Dynamic configuration. So just like this one. Uh, let's focus on this figure. So number one is router solicitation to all IPv6 routers. I need addressing information from the router. So this one, the router assignment to all. Here is your prefix length default gateway information. Let's go here in the dynamic link local address. So all IPv6 devices must have IPv6 link local address. A link local address can be established dynamically or configured manually as a static link local address. So just like this one. So this one and this one. Then number what's that? So this like is dynamic created link local address. So just take this one. And this one, routers EUI 64 generated link local address. PV ICMPv4 and ICMPv6. So, ping to a remote host. So that's all. Is it reachable? So, we'll ping that. So, then the exchange. So they ping using the H1, the H2. So they go to here. They check if they have the connectivity. Yeah. The IPv6 router solicitation and router advertisement messages. So I will send the RA every 200 seconds. So this one, RA messages are sent by the routers to provide the necessary information to hosts using SLAAC ICMPv6 router advertisement. So to all IPv6 routers will take us ICMPv6 router solicitation. I just put it up, so I will send an RS request on R. So just like they are sending and receiving. So ping testing connectivity to the local LAN. You can also use ping to test the ability of a host to communicate on the local network. This is generally done by pinging the IP address of the gateway of the host. A ping is a gateway so you can ping the default gateway. So just like this figure. So you will ping the default gateway. So this one, the IP address of this one. So you will ping if your IPv4 has the connectivity to your local network. So we'll ping. So just like this one, ping 10.0.0.254. So if they have a four replies, so it means that they have a connectivity. Summarize this activity. So most of this activity is all about the IP addressing. So from the title itself. So it is about the converting the binary into decimal and converting the decimal to binary, and also using the IPv6 address. So that's all for this video. Thank you for watching.